level with this rod. Now with this rod, it is a deep penetrating rod. And when you're going to make your welds with it, you're going to do what's called the whip and pause. You're going to get your puddle flowing, move forward a little bit, and then come back.
Cruising on Cespa in my DeLorean. War's over, I'm a piece of Mandalorian. The story is some Star Wars historians. Deep in debate, but they play at Bennigan's. Round renegade, show to penetrate first.
Now here's an older 6010. This is a 1/16 inch 6010. This is the old red-coated Lincoln one. This is a Lincoln too. This is the older one. And same composition basically, but a difference in size. I'll bring it closer so you guys can see it. Now there's the two rods side by side. You see the difference in the diameters on those guys? All right. We'll have a demonstration of that as well as the MIG welding coming up here in a few minutes. On to our next process. Okay. In 3, 2, 1. All right, our last process we're going to talk about today is TIG welding, or GTAW. TIG stands for tungsten inert gas, and the GTAW is gas tungsten arc weld. They mean the same thing. The AWS proper name is GTAW, but just about everybody you run into is going to call it TIG welding. If you run into some older folks, they may call it heliarc welding, but it's all the same thing. Now, in this process, you're going to use a TIG torch that has this nice big thick cable in here. Now, in here is a gas cable and a power cable. In my particular torch, there are two separate cables. You can get them that have it as one. And let's take apart the torch and talk about it for a minute, okay? First, we have the back cap. And all the back cap is doing is tightening the collet to hold your tungsten electrode in place. This is the tungsten electrode. This is a full 7-inch one. If you can see the color there, blue, that is 2% lanthanated, and it's good for almost any metal. Now in this hand, I have the collet. This is a 3/32 electrode. This is a 3/32 collet. The electrode goes through the collet, like that, and into the collet holder in the torch. Now in this particular torch, instead of a standard collet holder, what we have is a gas lens. Now if you look, there's the side view. This is the torch body part here. This is the gas lens. That hole right there is where your tungsten electrode comes out. And this screen around it is the gas lens. And there's actually 4 or 5 screens in there. And what that helps to do is to even out your gas flow. For TIG welding, we're using 100% argon. You cannot use a MIG mix, no carbon dioxide. The only exception for a mix is if you're going to weld some heavy-duty aluminum on AC or something like that, and you need a little bit more heat, you can go with a helium-argon mixture. Sometimes you can even run 100% helium for real good penetration. But the argon is important because the argon helps start the arc and keep the arc. All right? So let's put our torch back together. There's our gas lens. Now this is the cup. This is a ceramic cup that covers the lens and shapes the gas flow. These come in different sizes. and in different materials. You can get a gas lens made from clear Pyrex so you can see through it. I'm going to put the electrode and the electrode collet through the back. Now you can see it sticking out the front. I put my back cap on and tighten her up. Adjust my length. I like about a 1/4 inch stick out. Now this torch is a flex head torch. I can put the head in any position that makes it easier for me to weld with. Now, my machine is what's called a high frequency start. Some machines are lift start, some machines are scratch start only, and I'll explain that to you. If you have a machine that is scratch start, and that's what a lot of the older machines are, and if you have any type of an arc welding machine, you can TIG with it just by clamping on a TIG torch and adding some gas. But in the scratch start process, you actually need to take your torch and touch the tip to the metal and make a little scratch, and that will start the arc. Now in lift arc, you put your torch down like this, and you rotate it and pull it up, and that will start the arc. In high frequency starting, which is what my machine has, there's a circuit in the machine that creates a high frequency spark that travels between the electrode and the surface and initiates the arc start. Would you like a demonstration? I'll show you, but don't tell Mr. TIG I did this. Are you watching? Finger, torch. Can you see it? Let's try it on here. Maybe you can see it better. Do you see the spark? That's the high frequency. Now, TIG welding is my favorite process because it is the most precise, and it's like surgery with metal. If you're going to MIG weld, you can literally do it with one hand. You get your angle right, you squeeze the trigger, you go. If you're going to stick weld, you can absolutely do it with one hand. I do a lot of my stick welding with one hand. You know, I get the electrode in the holder like this, and then I grab onto something to brace myself. And I just hold it like this and do my welding. Well, you can't do that with TIG welding. TIG welding, you need 3 hands, or 2 hands and a foot. And let me show you why. Clean off some of this stuff here so you have a better view. All right, in TIG welding, we have our torch. You can hold it any way you want. Sometimes I hold it like this. Sometimes I hold it like this. Sometimes I'll hold it like this. Sometimes even upside down. It doesn't matter as long as you get the correct gap. But this tungsten electrode is not consumable. It's not like the wire in the MIG gun or the stick in the stick welding, which melt into your weld. This electrode does nothing but transfer the power, the electricity, the arc, from your welding machine to the surface being welded. Now, there are some type of welds called autogenous or fusion welds where you don't need any filler material. if you have a nice clean joint, say an outside corner joint where you have two pieces of metal at a 90-degree angle like this, you can just melt those two edges right together. Makes a very nice joint, but it's not particularly strong. So, what we need to use is a filler metal. This is a 36-inch long, 1/16-inch thick piece of steel. This particular filler is ER70S2. ER stands for electrode rod. 70 is 70,000 psi of tensile strength. S stands for solid, and the 2 stands for the composition. So here's where we're at. I've got my torch in one hand, and I've got my filler rod in the other hand. And as I am moving the torch along, I'm dipping my filler metal. And of course, this is what's melting and getting shorter, so you just need to learn this little trick to move the metal along in your hands. It's really simple. You pinch with the 2 fingers, and you move it forward. Then you grip with your thumb, pull back. Pinch, pull, grip, pull back. So that's your 2 hands. Remember I said it was a 3-handed process? Well, you can TIG weld just by setting your amps on the machine. But for the most precision, and what a lot of guys use, is a foot pedal. Trying to get mine out here. Hang on, guys. Seem to be tangled up on something. Okay, here we go. A foot pedal. Now, inside this foot pedal are 2 things. There is a switch that activates the high frequency, and a potentiometer that, as you step on the switch, increases and decreases the amount of power being applied, the amps. Also called the heat setting. More amps equals more heat. So I'm going to give you a demonstration of this process too. There's a lot to take in today, I know. That's why I said it was a very special episode. To do the demonstration part of the show of each of the different processes we talked about earlier, we're going to be using this 6-inch long, 2-inch wide, 1/4-inch thick piece of mild steel. And I'm going to run a bead from each process, and then we'll look at them and talk about them. So, the flux cord arc welder. I'm going to get started. This is the one where you can do with one hand if you like, with the gun. Very simple. The wire feeds out. Alright, you ready? Here we go. Looks like I have a little issue with my wire feed, so, and we'll pick up from where we left off. Still having some trouble. We'll give it one more try. So there you can get a nice look at the flux core. All right. Next, we're going to do the stick weld. Is in the electrode holder, the stinger. Whoa! That's live. You got to be careful with that. All right, here we go. There's our bead for that. Again, it's covered in slag, which we'll have to clean off, but that's really simple to do and will only take us a couple seconds. Is that the flux core was using 0.35 wire, or 35 thousandths of an inch wire, where we were using a 1/8 inch stick electrode there. But you see how easily that slag just chipped right off of there? Nothing to it but to do it, right? All right, finally for our last one, we'll be doing the TIG weld. Material, this is the mild steel ER70S2, 1/16 of an inch. I've got my torch. This is the flex head torch with the gas lens, 3/32 2% lanthanated tungsten, and I'll be pushing this way and adding filler. Are you ready? All right, here we go. Something's wrong. I didn't put it back in the high frequency start mode. Alright, here we go. Get our puddle going. Dip, move and dip. Taper off slowly. And there's our TIG weld. Let's take a look. It doesn't need any cleaning, but I'll just shine it up for you a little bit. The argon that we use for the shielding keeps all of the contaminants out. All right, let's have a good look. There's our TIG bead. Very clean. And here
flux cord bead, and our stick bead. TIG, stick, flux cord. And there you can see all three of them together.